Good to go. Swapnil, we lost your screen. Okay, you're good.
Okay. Hello, welcome and good afternoon, everyone, to the Fall 2025 seminar series. Today we have here Dr. Vishal Singh, who will be giving his presentation. But before that, I would like to introduce the graduate student community leadership team. I'm sorry, my screen has been frozen for some reason. Okay, yeah. So, the 2025 series. So this is our leadership team for the year 2025-2026. We have our two co-chairs, Rodney and Samuel Espinosa. Then we have the publicity team, which is me and Avinash, and we are responsible for sending you the emails out regarding GSC events, the webinars, uh, everything related to it. And then we have our co-treasurers, Priyabash and Pinchu. Coming to our support team, we have Zareen, Lois, Roshan, Rachel, Narayan, Thomas Sadikur, Suramya, and Viva. And if you see, we have students from a different variety of the schools and the Dyadic College of Engineering. And we encourage the other graduate students to join us as well. And then we have our mentor, our faculty mentor, Dr. Farooq Mistry. He has been a great help in setting up GSC events and everything around it. So the GSC has regular on Thursdays at 4:30 p.m. The meetings are usually held on Zoom. And if you would like to attend them, please contact Samuel or Rodney. Their email addresses are right here. You can also just type their names onto the Outlook, and then you can have their emails from there as well. Our GST meeting schedules are flexible according to the students' availability. So if the 4:30 time uh, is not suitable for you, you can reach out to us, and then if you're regular, we can change the meeting timings to something that is suitable for everyone. You can become a member of the GSC on Engage. So for that, you can either go to the Engage webpage and search for either student community, and our page should show up. Or you can also use the QR code, which will take you to that page. So I'll give you a couple of steps. If anyone wants to join the GSC on Engage, you can use this QR code. Okay, moving on to our LinkedIn page. So we regularly post the updates on the GSC webinar and the other events on LinkedIn. So if you would like to join the LinkedIn page, I advise you to please scan the QR code over here, or as usual, you can also search on the LinkedIn search for the graduate student community, and our page should show up. The GSC also has a Facebook and Instagram page where we regularly also post information about our events. So you can search for the OU graduate student community on both the platforms, and you should be directed to our Instagram page. The Instagram page was recently opened, and then you can see all our upcoming event notifications through their Instagram page as well. We also have a YouTube page where we update the previous week's webinars to it. So if you anytime miss any of the webinars, you can go to the YouTube page. Just look for the student community on YouTube and our page should show up. So if you miss any of the webinars, you can catch them up later on the YouTube page as well. Okay, so the GSC leadership team is its own team room. It's called the Dave and Susan Bird team room. It's located in the engineering laboratories building right across the Felder Hall building. It has all the amenities such as couches, whiteboard, coffee pots, microwave, and if you would like an access to this room, you can email either Samuel or me to get an access to this room. A quick reminder, in a few minutes, we'll be uploading a link in the chat for the Google sign-in sheet. This helps us keep track of the people who are attending the webinars, and it gives us a chance to show to the, it gives us an opportunity to get funding for the future webinars as well and the other events as well. Okay, into this coming to the fall 2025 webinar series, we have a theme which is exploring research frontiers with generative AI, its issues, methods, and applications. So the GSC webinar series is bringing together leading voices from academia and industry to explore this topic. And we see future speakers who can address one or more of the following themes. How people can work with generative AI to create intellectual, economic, and social value and connect those domains. The second one is research issues, methods, and applications that arise when people collaborate across research, industry, and community. And the third one is ways for people to design generative AI initiatives that link academic inquiry, economic innovation, and social benefit in ethical and equitable ways. So if you or any person, anyone else you know, can provide insight over these topics, do email us and let us know, and have them on our future webinar. Coming to upcoming webinars, we have Dan Fisher and Dr. Liu from Oklahoma State University, and they will be talking about will AI make or break engineering career. October 23rd, we have ASME Lightning Talks, which has a topic of engineering and AI. In these lightning talks, we'll have three graduate students who will be talking about their work based on this theme. And on October 30th, we have Rebecca Husky from the College of Arts and Science at the University of Oklahoma, who will be talking on ethical AI. What do we gain? What do we lose? Okay, so with that, I come to today's presentation. We have Dr. Vishal Singh. He is an associate professor in the Department of Design and Manufacturing at the Indian Institute of Science, Bangalore. His research lies at the interface of design thinking, system thinking, and computational thinking. His work integrates these paradigms to explore the systematic dependencies between products, processes, people, and policies across various socio-technical contexts, with major areas of interest in built environment and construction management. This also includes digitalization, Industry 4.0, and smart manufacturing, built environment, adaptation and trust for built environments such as modular construction, building accessories, and equipment. The Indian Institute of Science, he leads the Impact for Impact Lab at IISc, where his group investigates design innovation, human-computer interaction, digital twins, and decision support systems for the built environment. Before joining IISc, he was a faculty member at Aalto University, Finland, where he led the Aalto Building Information Modeling or BIM collaboration initiative and founded the Integrated Construction Informatics Lab, or also called as the ICONIC Lab. Today, the speaker will speak on the topic are generative AI and LLM in human-computer dynamics, insight to how emerging intelligence systems influence autonomy phases and collaborative decision making. With that, I give the floor to Dr. Vishal Singh to start his presentation.
Thank you, Swapnil. I hope my audio is clearer. If somebody could just let me know if you have the same issue. Oh, okay, great. Thank you. Let me share my slides and then I'll get started. Right. Just one more minute. Are my slides visible? Again, just a feedback will be helpful.
Yes, your screen.
Okay. Great, thank you. So thanks, Swapnil, for that very extensive introduction. And then as I was reflecting, I thought the title, even though it says Are Generative AI and LLMs Reshaping Human-Computer Dynamics, I think that's kind of obvious. So it's rather the question should have been, how are generative AI and LLMs reshaping human-computer dynamics? But that said, sort of let's look at and what we are going to. I'll take a perspective which is much wider. It was more conceptual in nature, though I'll start with some examples of what we have been doing. And it was great to hear from the audience and see the diversity. So I hope the talk in that sense fits well with the audience. I'll also, as we progress, try to not get into some of the details which are there in some of the slides. So I'll skim over them. But feel free to interrupt as we go along. I think the best would be to keep it as interactive as possible. So I'll also pose questions in between, and I'll only progress if there are answers from the audience. So with that, I'll sort of get started. Thanks again for having me. It's wonderful to be part of this, and it's a great initiative to see on a topic which is extremely relevant, and there's a lot of uncertainty in terms of how we deal with it, given that the pace of development is very fast. And I think that's one of the biggest challenges that we are dealing with. Very exciting, but that's where the excitement brings a little bit of uncertainty as well. So Swapnil has already sort of talked about my group, so I'll not go into details, but very quickly, there are three broad areas of research. One area we look at is the domain-wise. We focus quite a bit on the building industry. That's largely because of my legacy thing, that because I started my academic career in construction, then moved on to design and then to computing, and then again went back into construction as a faculty in Aalto and back into design when I came back to IISc. But we look at a number of, within construction, not only look at the design, but we look at technology. So for the last 15, 20 years, I've been working on information systems and computational models. And some of the things that I'm going to talk about started during my PhD itself. So I'll talk very briefly about my PhD topic as well. Alongside, over the years, I've been trying to understand what my own research is. As you mature and grow gray hairs, you start to realize what you have been really trying to do. So I would say my research sort of lies at the interface of design thinking, systems thinking, computational thinking. So systems is the key word there, and trying to then convert it into computational form. and taking a design perspective. When we say design here, it takes Herbert Simon's view of design, which is much wider than what we normally perceive in engineering or in the lay terms. So design here would be any intervention which seeks to have a plan to move from an undesired state to a desired state, right? So you could be designing policy, you could be designing your career, designing your life, or designing a product, right? In all of these, you are trying to move from an undesired state. So something in the current state is not necessarily the best that you have, and you would want to improve it, right? So that's your desired state. And that intervention is design. So
we should write that down, find the Herbert Simon quote.
Sorry?
Sorry.
Right. You wanted me to say something about it, or?
I think what you said is very nice, and if you could expand on it, that would be neat later on in your talk.
Sure, we'll do that. All right, great. Yeah, we'll do that. Thanks. Yeah, and then the other side of the research has been that, okay, as researchers, we tend to innovate. That's our mandate. But many of these innovations don't end up necessarily at the speed or many times never into the ecosystem where we want to take the innovation to. So the other aspect of my research looks into how do you understand innovation ecosystems. So in that sense, it's a fairly broad research group. I have about 12 PhD students working in various areas, looking from construction to psychology and a range of topics. But I'll come directly to the topic at hand right now, starting with some of the references. So don't worry about the density in the slide. I just wanted to flag the kind of research we have been doing, which is related to the topic today. So my PhD, for instance, I submitted it in 2009, and this was in Australia. And here, what I was looking at was using agent-based model. So basically, essentially studying social dynamics and groups. The focus was how team members learn about each other as they are involved in a project, and how does that knowledge of each other improve the performance of the team. And so basically, the team members build a mental model of each other through social learning. So you basically observe people, what they are doing, you talk to people, and you see people doing things, and from there you get to know what their capabilities are, and then you leverage them to perform tasks. This was entirely done through computational models, which was great because it helped me sort of narrow down to very specific parameters. And part of that led to a concept which is very well known in psychology and to some extent in computer science, that is of transactive memory systems. And I'll come back to that because that's one of the core constructs that I'll talk about, which is important when we start to use tools like machine learning or otherwise, any tool for that matter, any decision support system which aids a person to make better decisions becomes part of their transactive memory system. I'll explain what that is. So I just thought I'll highlight that. So that started already way back during my PhD. And for a while, of course, then as things happen, I ended up looking at information modeling in construction, which was not very related to my agent-based modeling, but at least I was still in the space of looking at information modeling and information management in a construction context, which was still focused on multidisciplinary collaboration platforms. So how do you get each stakeholder on the same collaboration platform? And so it's a group decision support system. Information is getting exchanged. So the contextual background of why this is relevant is because we are already talking about teams, and we are talking about information exchange. We are talking about people getting to know each other and their capabilities. And this becomes central to what we are looking at today, which is saying that if you are working along with artificial tools, generative AI or machine learning or otherwise, it's a human tool collaboration, which is not very different from human to human collaboration. And that's where it's worth looking at is what can we learn from what we have experienced over the years about human-human collaboration that we can take to human tool collaboration. And how are these new tools like the generative AI and your LLMs or the agentic AI different from what we have been traditionally using until say 2017, 2015, before these attention models and other things started to really come in. and more recently, of course, with GPTs of the kind that we are looking at, right? So the objective is to highlight some of those questions and then connect back my own experience, because the pace of development in the research in this space has suddenly become very different. What used to take us, so in this, some of this research that we did, which I've listed on the top right, it was much slower than what it is today, right? Today, things are moving so fast within LLM space as well that it cannot afford to even conduct research at that pace as we used to do almost 10, 15 years back, right, in some of these space. Alongside the other kind of research that we have been doing is to look at generative design. Now, generative design as a concept is fairly old. Generative AI is relatively new, but generative design has been around in the design literature since 70s or 80s, or even earlier for that matter, starting with parametric models and geometric ways of looking at generative design, procedural modeling, and so on. So there I wanted to highlight a work that we had done around 2010, 2011, where we are looking at, so typically when we talk of generative design, until the procedural model kind of era or evolutionary computing kind of models, you would make commitment of which kind of approach you take. So for example, there are tools like cellular automata, you have agent-based models, you have shape grammar, and so on. So you use different kinds of generative models to generate design using parametric approaches. And these approaches will typically not be interoperable, because you make the commitment once and then midway through the design, you cannot switch to another form. Whereas humans have this capability of being able to see patterns and see, okay, we started with, let's say, cellular automata, something has come up which is interesting, and I can probably switch to some other form. So that is what this paper at that point in time tried to sort of highlight. And we were at that point in time thinking of strategies of how to move towards an integrated generative design framework. And at that point in time, the idea was that it would be through some sort of a translation model. So translational thing to where you could do a mapping between one representation to the other representation, and you could try to translate from one form to the other. When we started this project again around 2020, and there was a gap in between for a long time. When I came back to India, then we sort of started working on that topic again, around 2022 rather. And as soon as we got the project, LLMs became very dominant, and we suddenly realized that our approach, which we were thinking, did not fit into the current times, because LLMs offered a very different way where we could sort of, the complexity of trying to achieve the same interoperability was dramatically reduced. So we changed the strategy. And then these papers came in, which was about knowledge augmented generalizer, spatializer. So I'll very briefly touch upon these, and then we started sort of leveraging large language models. So what was until 2010 for us, and there was a need to write a translator and many such, because you had to look at a higher level ontology to map it and things like that. Suddenly became much easier in terms of implementation, but also with the promise of the general problem solvers or GPTs as such. Right? Feel free to interrupt me if there's a question in between. So I'll very quickly have the next 3 or 4 slides were not there when I had shared the slides in the morning. So I thought I'll just add these. Initially, I had plans of not going into this, but I thought I'll start with this example because it will be much easier to then connect the dots. So here, what we at a higher level, the system architecture looks something like this. You have a platform which we sort of in the connecting RAGs, which is here somewhere. And then you have your LLMs. We sort of look at a tool which helps in early design stage. The idea of this tool is that you start with a very generic problem statement saying what you want to solve. For example, looking for an alternative for a design of a pencil, for example, right? And suggest what are the functions, behavior structures of a pencil. And then the tool starts to suggest, okay, what is the typical function of a pencil, and what are the typical elements of a pencil, and so on. And so you formulate a problem and you give it to the LLM. LLM has an encoder, or the architecture has an encoder agent which reformulates the problem to create a prompt. That problem is first sent to a research agent. Research agent already has a prior sort of ability to search on the web. and also has if there's a predefined database, it looks through that. That's where the RAG is, or else through the web search, if it finds something, it adds to the database as well. So that's a continuous process. It reformulates the problem, and then the problem is given to your LLM as a prompt, and then it starts to break down or decompose the problem. When the problem is decomposed, there's a scoring agent which sort of evaluates whether decomposition is correct or not, and so on. So this entire, I'm not going to go into the details, but the objective here was that typically when we have been using CAD tools, the problem is given either a traditional CAD tool, of course, the designer is the human agent, and you are using the CAD tool as a modeler or as a drafting tool or otherwise. Over a period of time, when we talk about generative design and others, we have started to create rules or create procedures through which the design is generated by the computational tool. Now we wanted to go a step further, saying even the tool helps us formulate the problem itself. How does it help us getting the problem formulated better? Problem formulation is a very critical part of design, right? So if you are from the design thinking background or design background, finding the right problem to solve or formulating the right problem in itself is half the problem solved, right? Because if you do not formulate the problem right, you might be solving something which is not going to necessarily resolve the issue that you want to resolve, right? So problem formulation by itself is a very critical step in design. So here, as part of the implementation, we worked on what is called the function behavior structure ontology in the engineering design literature. I'll move and briefly explain what that ontology is, and I'll take an example to run you through so that those who are not familiar, I'm assuming most of you are not engineering students, I'm hoping would have some background in it. But I'll still run through with a simpler example so that it helps everybody to be on board with what it is. In the first glance, intuitively, you'll get it. But when you start implementing, it's fairly complex because it's so simple that the simplicity is not easy to sort of then grasp when you're trying to implement it. So what essentially it says, so function behavior structure ontology sort of was proposed in 1990s. And it says that when you start to look for trying to solve a problem, you start with some requirements. And when you study the requirements well, you formulate the problem. So you define what exactly you want to achieve. What is the purpose? The function is the purpose that you want to achieve from a design artifact. For example, so let's take the example of a receptionist. So I'm not even going to take a product. Now, let's say you want to hire a receptionist for your office, right? So what is so you know that receptionist has a function to do, which is to function as a receptionist. Now, if you are going to be the person who's going to create the job description of a receptionist, you have to have a few desired qualities of the receptionist, right? So you might say, so what is the desired qualities of a receptionist? Any suggestions? Let's say you are to hire a receptionist for your office. What would you like to have in the person that you want to hire as a receptionist? What characteristics?
I would say they need to be detailed.
Oh, they need to be detailed. Very good. So they have to have attention to detail. What else?
Organized.
Organized, polite, maybe multilingual, and so on, multitasking, and so on, right? So you are describing a certain set of characteristics of behavior that they must demonstrate. All these behaviors collectively lead to them to be able to function properly as a receptionist, right? So what you have is from the function description, the function that you want to achieve, you have an expected set of behaviors. Now, when you have that job description where you list, let's assume that you have defined some 10 characteristics or 10 attributes of a good receptionist that you're going to hire. Now, when you're going to interview candidates, you're going to assess them against these 10 characteristics, right? So each candidate is a potential solution. So that is the structure. So you are evaluating, when you are interviewing them, you are evaluating them, their actual behavior. So this is your expected behavior, which will meet your requirement or function. And you are evaluating their actual behavior. So you are comparing them. So now let's say I had listed down 10 actual behaviors, expected behaviors, and the first candidate only met 4 or 5 of them. So probably not a good candidate, and so on. So I keep going through multiple candidates and keep evaluating their actual behavior against the expected behavior. And if a candidate meets all of them, great, then I have a solution which is acceptable. Now, let's assume that none of the candidates that you interviewed met all your expectations. What would you do?
Either change expectations or look for more candidates.
Right. So I can continue looking for more candidates. That is my reformulation one. So I'll still keep looking for more candidates. or I change my expectations. So I relax some of my conditions. I say, okay, maybe only 7 or 8 are mandatory. The other 2 or 3 characteristics were ideal, but okay, fine, I will go ahead with it. Now let's assume that even after changing your expectations, none of the candidates seem to be fitting your requirement or requirement or the purpose. What would you do?
I think sometimes we need to change the function as well. The whole goal that we define at the earliest stage.
Yes, absolutely. So right now, for example, let's say you might find that, okay, nowadays, all the things that we want from a human receptionist is not happening. So we'll totally do away with it. We say, let's just put up a kiosk, which will welcome our guests. So it will be a kiosk, which will be meeting some of the functions, which is basic saying that, if somebody comes, it will greet them with a polite voice, Alexa there, a nice touch interface or whatever. So you take some of these characteristics, but you have redefined the problem itself, saying amongst people, we are not finding any good people these days who are good for being a receptionist. I'm just making it up, but point is that there are different ways to reformulate the problem. Now, we took the example of a receptionist here, but you get the idea. The idea is that this entire design cycle, from starting with the requirement to problem formulation, to actually going through the iterations to look for the solution, and finally documenting an acceptable solution, the entire iteration of the design cycle is well explained in Jiro's model of the FBS, right? So what we did in our implementation of CAGs also, we wanted to start with the same process. The user gives the requirement. The system, which is the LLM in this case, together with the RAG database, sort of goes through this iteration of decomposing the problem into the function behavior structure, goes through this iteration, and then proposes solutions. So now, and that is what we were trying to implement, and we had some insights into that. What we found was that we got reasonably good performance. There were a lot of challenges in between. Those are reported in the paper, so I'm not going to go through. Just to take the idea forward, why this was important, I'm just going to give the theoretical background of it. Now, design as such is a continuous or co-evolutionary process, right? So when you start solving a design problem, you do not necessarily understand the problem well enough. You might think that you understand the problem well enough. That's where we talked about the importance of problem formulation and reformulation, which we just discussed also. That as you progress, you get better understanding of the problem. And this is already well documented in the literature, which says that at the point of time t, you think the problem is p, so you solve it. When you solve it, then you get some insights into the problem, based on which you sort of find the next definition of the problem. And then you try to solve that and so on. So it's a continuous process. Design is a never-ending process. Going back again to Herbert Simon, one of the other things Herbert Simon said, which is actually very important from anybody working on AI, is the concept of satisficing. So if you're familiar with the concept of satisfying, or if you're not, so you should actually check Herbert Simon's book, The Sciences of the Artificial. I will encourage everybody to read. So Herbert Simon, if those of you don't know, was a Nobel laureate in economics, and also one of the fathers of modern AI. And the concepts of bounded rationality and satisficing were extremely critical part of re-looking at AI, because the idea that you'll always have an optimal solution does not work in real-world problems, right? Real-world problems sometimes take extremely long time to solve. First of all, for most problems, you'll not have the complete information to start with. So if you're waiting for complete information, you never start solving the problem. And that's where satisficing becomes critical. So satisficing essentially says that you are not necessarily looking for optimal solution, you're looking for good enough solutions, which means that what is good enough, you have to stop for whatever conditions. Either you have run out of time or you have run out of resources to solve it further. So whatever you have, you accept it as if it meets your requirement adequately, you go ahead rather than seeking optimal. Now, if we take that in a longer temporal sense, this is what we see even, let's say, the history of your function is to lit up a dark space, right? So at some point, people found a solution, great solution, which was a candle, right? It would lit up a dark space, and for a long time, people would have innovated incrementally within that space. But then there were problems with the candle. So when there was no candle, candle was a great solution, right? At that point in time, it solved the problem of lighting up a dark space. But then it had problems. If the wind comes, it blows off, it sort of melts very quickly and so on. So at that point in time, the problem was how to light up this place. Solution was a candle. Then candle had, when we started to evaluate, had many problems. So then somebody came up with this lamp. This lamp solved many of the problems which candle had, so it became much better solution. But then this over a period of time was found to have its own problems. Then we moved into electricity-based bulbs. Your incandescent bulbs had problems of something else, where energy consumption and so on, which means that it's a never-ending process, right? Even the best of the solutions that you have right now, you'll find a problem with it to improve, and then the next generation solution will address on those problems and so on. So this cycle of design will continue. Now, this is, again, what it means is that in your problem solving in the AI system as well or otherwise, if you go through the same iterative process, it's very unlikely that you give just one problem definition at the beginning and then it ends up in an optimal solution, right? So you'll have to go back and forth potentially in that. So that is what we were trying also with our CAGS framework. So just to take the idea forward for some realizations, very quickly, I'll do an exercise with you. I'll not take a lot of time because this exercise by itself takes a lot of time. So I'll need some quick responses and then we'll move on. This is just to show that when you think of things intuitively, you miss out on so many details. And that's why many of the solutions that come out of current generative AI, which looks fine, may not have all the details adequately. And we know those challenges with the current GPTs and the way they function, because they largely function on statistical models and of course, deep neural networks and things like that. So let's just start looking at to begin with a problem of defining what are the functions, behavior, structure of a pencil. What I want you, so the problem that I will ask you right now is that what is the most abstract level, at the most abstract level, what do you think is the function of a pencil?
To leave a mark on any surface, say paper.
Right, wonderful. So usually I don't get this answer. Usually people say to write or to draw and things like that. So I'm great to hear that you have directly come to leaving a mark, right? Now, so you have got your function defined, which is to leave a mark. That's great. So make a mark. Now, what kind of mark? So just like we talked about, just like we talked about the function of a receptionist is to be a receptionist, for instance, and then we said there are certain expected behavior, right? Now tell me the characteristics of this mark. What kind of mark?
Light and dark in terms of pressure applied. So it can be, I mean, I guess characteristically it can be it can be a random straight line or it can be a contour. But
right.
In terms of, I guess would be the first thing. But then if I'm looking at it, I can also say if it's dark or light.
Right. But have you already assumed that a mark has to be visual all the time?
Yes, the assumption is that the mark is visual. Yes.
Right. So you see that you have an assumption, which we tend to have, right? So the first itself, we can ask whether is it a visual mark, oral mark, olfactory mark, and so on, right? I can have a tactile mark, right? What other characteristics could be asked? Because now I want to, I do not want to necessarily replace a pencil only. I'm saying at the most abstract level, whatever function it achieves, which is to make a mark, I want to replace that function and get something else to give me that function. Right. So as you said, the most abstract level is to leave a mark, and that mark need not be visual. Now that I've given you that hint, what other kinds of characteristics can you say which are related to a pencil, or at the most abstract level? You had something, you said controlled versus random, right? Anything else?
Like if it's a pencil or something, then it's like ease of holding it, so that like ease of access to it, so that the person can.
Yeah, so don't be limited by pencil only. As I said, at the most abstract level. So of course you are looking at something which is very concrete, which is a pencil at the moment. But if you abstract it further, what else could be characteristics that define it? So basically, if you were to specify without any assumptions left in your specification about a pencil, what all will come?
I would say physically robust.
Physically robust. Okay, very good. What else?
The make of the pencil, like the quality grade of graphite or lead.
Right. Okay. So let me sort of, in the interest of time, move in this. So is it an additive mark or a subtractive mark? Is it possible to have a subtractive mark which is visual? Let's say you take something sharp, a knife, and scratch on a rock, and you write something. Is it possible?
Yes.
So then you have to specify, right? So a pencil gives you an additive mark rather than a subtractive mark. It is erasable. I can have a mark which is non-erasable. Again, as I said, I'm not talking only pencil. I'm saying if I have to specify, then I must say that a pencil gives you an erasable mark, right? It's a non-permanent mark. It can be, the color was already mentioned, whether it is faint or visible. So you have to talk about the contrast. You talked about random or controlled. It can be a small mark or a big mark and so on. So the purpose here is the purpose of doing this exercise is to say that when we solve problems as humans, and when we intuitively solve, there's so much we already know about the problem that it doesn't occur to you what assumptions you are making. So a lot of assumptions remain implicit in your problem solving. And hence, when you work and function at the intuition level and not the first principles basis, you will miss out on many of these details, which can come when you start to work with first principles basis, right? And this is what we found when we worked with, when we used the FBS ontology, when we were doing this CACS framework, is that the solutions we were able to generate, of course, because the solutions are based on a large amount of data set, and it will essentially take what is in the large data set, right, in the public domain, were largely driven by intuitive mapping. So basically statistical mapping of what a pencil is to some other function and its behavior and structure. But right as of now, we do not see a lot of causal reasoning happening in FBS, in the LLMs, right? It's largely inductive reasoning. And that's where the right kind of ontology, right kind of prompt engineering can be extremely useful. Just to illustrate the point that the human generative AI or human LLM collaboration is extremely critical. And this is something we already know, but we face this during our design process, and we are working on this to take it forward. I'll leave this part. I'm not going to detail. We don't have that much time. So coming back again to the topic of this presentation, which we said is about how sort of these things are changing the human-computer dynamics. I'll approach it in this way. First, we have already talked about, let's say, a person engaging with an LLM, for example, like what we did. Let's say if you're trying to solve a problem or trying to generate some early solutions, alternatives for a pencil using LLM. So this is an individual interacting with the tool, right? So now individual has the autonomy and they interact with the tool, but the individual's autonomy is affected also in the individual in the society interaction. So agency becomes important. This is one concept we'll touch upon. Second concept, which is related, of course, when we talk about society, one way to think about society is teams and projects, but it becomes different now. So one is that an individual is functioning as an individual, but is part of a society, right? Which means the person is not responsible to somebody, doesn't have to have a collective goal with others. They can have an individual goal, meet their own objective, and have all the freedom to take their own decisions. But when they're part of a team, then you need to have a team mental model. You need to have awareness of what the team wants, and you do not have entire complete freedom because your decision making is tied with what your team members want. So you need to know about your team members, your responsibilities get distributed. So there's a breakdown that happens. So within the society as well as an individual, when functioning in a society, we'll have power dynamics. Somebody will have, any society for that matter, will have people with different capabilities and different resources and different situations, which will lead to an unequal distribution of power in the society. And that is true also typically in a team and a project, right? So a society, a general group will differ from teams because of the collective goal and things like that. Now, when we have a team, as we discussed, as I said earlier, then why do we form teams? We form teams because no single individual can do all the tasks, which means that you form teams of people with complementary capabilities such that the roles are distributed. The team's knowledge is also distributed amongst different people. This is where the transactive memory system comes. So I'll maybe explain very briefly, and I'll come back to the slide on transactive memory system a couple of slides later. But I'll explain this with a couple of examples here. Now, let's say how many of you remember more than 10 phone numbers now? Anybody?
Not at all.
Pretty much nobody, right? And why we don't do it? Because we know that those numbers are there on our mobile phones, right? And that mobile phone is always with you. And which means that whenever you need that number, you know where to find that number. Now, before the mobile phones came, we still had computers, but nobody left the numbers on the computers. You will typically carry a notebook of a phone numbers, correct? Which means that your mobile phone is an extension of your memory, which you can transact with when you need. Similarly, in a team, you know that, okay, if, let's say there's a team of 3 people who have just formed a startup. One guy is handling finance, one guy is handling technology, and the other guy is doing business. If something comes about the business, the technology guy knows that he can go to the business guy and ask what it is about business. The technology guy need not know about the business. So what you have done is you have distributed the organization's memory into different, so it's a distributed memory system. And the way it functions is you know where to find the information when you need it, who knows what. Then you also have to have a strategy so that if a new information comes about business, it should be passed on to the business guy, because the business guy is the expert on business. So that you keep retaining the specialization of the person, so that that person remains a specialist. If everybody knows everything, it becomes a redundant system, right? It's a waste of resources. But the problem with if nobody has any redundancy, then if the guy who was handling business, he leaves the company, then you are suddenly without that information. So now you see that when you have distributed knowledge or distributed memory in an organization or any of this, so let's say you lost your phone, for example, and let's say you did not have it on cloud, your numbers and all, suddenly you have to collect all the information again. So you need to have a backup strategy and so on. So now you see that the moment you are dealing with more than one actor, you need to have a strategy of how the sort of information is managed. So all of that. So I'll come back to that, right? So transactive memory essentially deals, I'm not going into details of it. I'm just touching upon these concepts because these become extremely important as we go forward. And because we are reliant on so many things where our information is stored, and so many places and so many technologies which help us achieve something, right? So the more capabilities you offload and rely on something else, the more dependency you build in the system. And that's where the power dynamics start to come, right? Because your dependence on your team members, dependence on your mobile phone, dependence on your other tools starts to make your tool very important. Suddenly, if you are without your phone for half a day, you start to panic, right? If the need be and things like that. So this is what we are talking about, where the power dynamics become extremely critical, when we are in an increasingly dependent, interdependent system. And that's again from a systems perspective, right? So we will very briefly touch upon how to think about strategies in this space. I'll again not go into too much of details. So now let's take a look at each of these concepts that we have looked at. So autonomy and agency. There's a lot of that written about what is an agent. So typically an agent, whether artificial agent or a human agent, is interacting with the environment. The agent has percepts, basically the agent senses things in the environment, has the ability to process the information and decides what action to take, right? And as a cognitive agent, which humans are, there are a number of capabilities that we have, from recognizing, categorizing to decision-making, perception, prediction, problem solving, and all of that. Now, when we talk about any decision support system, which is to assist a cognitive agent, that decision support system should augment one or more of these capabilities, right? It should help with all of these things. For example, let's say if I'm an accountant, right? Can you imagine an accountant today who doesn't work on a, say, spreadsheet? Or because it's now given that you have to know the tools of your trade. So once you know the tools of your trade, your ability gets augmented. You can achieve more than what you individually can, because the tools have additional abilities. So this is your decision support systems, or any tool for that matter, right? When we have a tool, the tools are there to augment your capability, right? Which means that this becomes the norm, that everybody in that community or in that line of work is using those tools. Now, imagine somebody who is an accountant today, but does not use any of these tools or any computational tool and does it manually. But it may be a great accountant, might have a lot more knowledge than the other guys, but because they are limited by the tool, they actually are not able to augment. So you lose out, right? So this, again, this is an argument I give with the students, essentially saying you cannot ignore the computational developments around you, because these are the tools you're going to play with. If you know how to augment your abilities, you look to be much more than what you are. If you don't know, then you are sort of behind the iron cage, and you are sort of constrained by your abilities, right? Now, what has happened over the years now is the nature of the tools have changed, right? So far the tools were more passive in nature, and now increasingly with generative AI, LLMs, and so on. First of all, the capabilities of the tools have scaled up dramatically. The second is the tools can also start to have a lot more agency, right? So since we are agentic AI and things where you pass on something, it does the task, gives you the solution, and you are not necessarily giving the input, right? So you can pass on, many of the things will get automated because the tools have greater agency. So this becomes extremely important to think how the nature of decision support is changing. But decision support is not just limited to, in a social context, it's not just limited to tools, right? Now, another way to think about decision support is also support system, right? When you have a family that helps you make decision, that's also a decision support system, right? They are also taking input from you. You are seeking feedback from them. You're doing a similar thing which you're doing with these other tools. So there's a knowledge base with other people around you. They also process the information, they give you the feedback, and you can then sort of take a decision, right? So you have two kinds of decision support systems. Your decision support systems where you have full control. You are the one which is giving the input and the output. You are deciding what to do with it. The second is decision support systems which have agency, which are around you, which see, and then which can, even whether you solicit an information or a feedback or not, they might proactively give you unsolicited advice or otherwise that you should do something or not do something, right? So the nature of agency in the decision support system also changes, and decision support systems can be both technical in nature or social in nature. And if typically in a socio-technical environment, which is what most organizations are, or society is by and now, where we are in a technology mediated society, and of course we have people and we have tools to support that. We are living in a system which is increasingly getting very complex, right? So you have technical systems which are passive in nature. You have human agents which are both passive and active in nature. And now you have technical systems which are active in nature and have agentic capabilities, right? So suddenly the complexity of your network changes dramatically, right? So what you're getting is that at the individual level, your individual capabilities can get augmented, and collectively individuals interacting, your collective capability as a team or as an organization or a network is getting augmented by these tools, right? And through both technical and social ways. But as we discussed, with the support that is coming, dependency and reliance increases to grow, right? Now you can't live without a phone, you can't live without X because you have got so used to, and you feel helpless if you do not have connection to the internet and so on. Now when the reliance and dependency comes, then the power starts to shift, right? So things that you are dependent on starts to build more power because they know that they have more power. I mean, so far, if it is passive system, it doesn't know. Active systems can start to figure out that you are more dependent on them, or the people who are controlling those systems will know that you are more dependent on them. For example, suddenly, let's say you do not have all the people who are offering browsers on the internet suddenly decide that none of the browsers will be free. I mean, they have the possibility to collectively go in that direction. Of course, there's a market with competition which takes care of that. But what prevents something of that nature to have a monopoly? I mean, in that case, not, but I'm just listing that as an example. And suddenly your dynamics will change because you're so reliant that if they still put a fee to it and unreasonable fee, you might still have to use it because you don't have an option, right? So this is what I'm trying to talk about when we are talking about power dynamics. Happens at all levels, within teams, in a smaller context, and at the societal level in the larger context. And with power dynamics, then suddenly comes the question of negotiations and trade-offs, right? So that is the chain of reasoning we are talking about. So on one hand, the tools started to augment your capability. And as a the reverse cycle, when you think of system dynamics perspective, the backward thing is that with all of these, with power dynamics, negotiations comes, and negotiations reduce your capability because they can curtail what you are capable of, because now you have to, despite your capability, which your tools augmented, eventually because of negotiations, there's a possibility that something limits your capability, right? So this is a backward chain in a system dynamics context. Any questions or comments so far? Am I going too fast or this is reasonable?
Completely reasonable for me. Thank you.
Right. And how much time is left? So sorry, I've gone a bit slow in some of those things. So if you could just tell me how much time is left.
I think we can do up to 10 minutes more.
Right. Okay. Then I'll try to run through quickly. I think the basic idea is conveyed. So I'll sort of, so then the question essentially is that aids vary in their agency and autonomy. And then we need to think about how they influence the dynamics, right? So I'm just now kind of in the state where I'm now reinforcing the same idea again and again. Now, this is where when we look around, if you look at the world around you as a socio-technical system, there are multiple kinds of systems here. So you have your software information systems. And now I'm taking this from the slides from my research group, such in terms of what we do, but it is applicable everywhere. So you are functioning in a social system. Basically, you're part of a team, a project, an organization. And if you're working in multi-organization context, your project will have multiple people from multiple teams. So that in itself is a system where there's a lot of power dynamics. Then you have your software information systems, CAD systems, all of them. There's a lot of interoperability issues within them. You'll have different software and different things will have interfacing issues. And then again, some tools will become more dominant, others not, so on. So there's power dynamics within this network in itself. Eventually, essentially what we are saying is that there are 4 types of systems. Each of them is a network in itself. And for the system, overall system to function well, this transaction of information between these systems must happen, right? So you need to have this is part of, as we said, almost as we discussed, phone becomes part of your transactive memory. Similarly, your CAD tools, your information systems become part of your transactive memory, organization's transactive memory. You have your modern hardware systems, which are intelligent in nature. They're also part of your distributed knowledge system. So then you need a strategy of how this system functions and what is the power dynamics within that. What becomes the dominant influence, what guides the organization, right? So your ERP systems may not be that easy to change because they are all over your organization, right? So the company that charges for ERP can then be unreasonable in their charging of ERP or your PLM systems because they know that their dependence is very high because you can't suddenly change an entire network-wise or organization-wise system, for instance. Another way to look at is, which we already discussed, we talked about people. Each individual is working with a set of tools. Now that collective individual surrounded by the tools, that's what everybody is, right? So we are sort of mediated by our tools, and then we are sort of functioning as the transactive group working in the larger system, which is a larger transactive group. So very briefly, if somebody is interested in looking at transactive memory systems, the concept sort of was proposed in 1995 by Wagner, and he talked about how, and he started a lot of his research initially was on couples, basically dyads, right? In a family, a couple sort of starts to have knowledge about each other, and then also the household's knowledge is partly with the one member of the spouse and the other, and so on, right? So he started looking at those things, how couples interact, how they function together, and of course that expanded to teams and many other things. The concept was always for everybody else, but the majority of study was done in dyadic context. And as I said earlier, very quickly, it talks about how you manage knowledge in a distributed system. And there are at least 3 key components of it, which is how the knowledge gets encoded in the system, in what form it is represented and where it is stored, how to store it, and then how to retrieve it when you need it, right? So you need to have a strategy for that. And that is what this talks about. So in our research, we have been sort of looking at what all are the characteristics that become important when you think about transactive memory system. And we identified 9 indicators. For example, we talked about in the case of a phone, you keep the numbers there, but you don't keep the numbers in the case of a laptop. Why don't you do that? Because phone is typically always with you, laptop may not always be with you, or a computer or desktop may not be always with you, right? So connectivity and access, how connected I am and how accessible the information is when I need it becomes one of the attributes, right? And these things, by the way, are human to human, information systems to information systems. This is not critical. This is just a framework. If you want to read about it, the citation is provided below. And of course, you can connect with me and I can get back to it. Similarly, in a distributed system, you need to have a strategy of how much of the knowledge should be allocated to whom, what should be the redundancy in the system. So basically, how much of knowledge overlap should be between me and another team member so that, we have some way to sort of coordinate things. How much do we trust the knowledge that is distributed? So accuracy and credibility, reliability and trustworthiness of team members. We talked about, let's say if there's a new information that comes about, let's say about finance, it must go to the finance guy so that his or her expertise is reinforced, right? So you have to have a strategy and so on. So I'll not go into details of all of these. Similarly, you have to have a strategy of backup and things like that. So there are 9 indicators through which you can evaluate this. Now, what I'm proposing here is that some of these assessment we need to start doing with all the tools that we start to have dependency on, or we start to use them as our transactive memory, where we use them as support systems. Not all of them are transactive memory because that's just an extension. And that's where my question was, that we so far discussed a number of other things in terms of power dynamics, transactive memory. So what does it have to do with generative AI and LLMs and agentic AI, right? I mean, there's a direct connect, but I think what is important then to think about is in what ways or what capabilities of generative AI, LLMs, and agentic AI as autonomous systems stand out, which are relevant to why they have become so much more powerful. So, for example, the question I'm trying to ask here, so I'll pause here and just extend that question a bit, is that before your chat GPTs and so on, there was still a lot of good deep neural network tools, and also even the GPT models were there, and leave apart the chat GPT one and things like that, which were not. Why did it scale up so much? Why is everybody nowadays able to use it? What do you see as the key feature which has enabled a wider adoption, where it seems everybody is using it now? What is the key differentiator? Any thoughts?
Accessibility and like ease of using it.
Absolutely. I think the idea that you are now interacting via natural language, the learning curve has gone down. You may not know exactly how it functions, but you do not have to now have a knowledge of how to communicate with it. So it's communicating with you in your language, which is your natural language. And that's a huge shift that has happened, right? So suddenly the barriers that were there in the using of other machine learning tools or other advanced tools until now has suddenly been broken, because suddenly people are interacting with the natural language and they're able to give prompts in a natural language and it's feeding back. So one of the major barriers in this transaction has been reduced. So when you start looking at these from now, what it also means is that more and more number of people are relying on for everyday things on these tools, right? And so you'll see suddenly an exponential change in the dynamics of the human computer interaction because of certain features. The backend capabilities were there, and may not be necessarily to the same scale, but by and large they were there. It suddenly did not happen in a day. What shifted this is the interaction and that barrier that was there in how people, and that's one of them, and maybe there are a couple of other features. But I think these are the things we need to start looking at in terms of when we try to look at what is the major shift or the tipping point. And if we understand those tipping point, what will its implications be in how it scales up or exponentially? And that's where the challenge lies, because it's happening so fast that it's very difficult to then catch up with it. So then, for those of you who are familiar with the Turing test, so do you think agentic AI or GPTs have passed the Turing test? So the Turing test is essentially, this is how the Turing test is set up. This was proposed way back by Alan Turing, which said that if a person is interacting with a computer and a human responder, they'll not be necessarily able to figure out which message is coming from the computer or the human responder. From your own experience of now how people are using it and using GPTs everywhere, including writing papers and so on, do you think the Turing test has been passed? What's the general sort of belief? So let's say if you get a paper written, would you be immediately able to tell whether it's written by a person or a GPT, or even a message for that matter?
I feel like you can still tell, usually pretty
getting
often.
blurred, right?
Yeah.
So there was a research actually, I mean, so there's a general belief in some places that it's been sort of breached, but there was a research actually done, I think in Berkeley or somewhere. I just saw it recently. I didn't go through the paper, so I don't know the details of it, but it did say that it's not yet breached. I mean, within 5 minutes, you can figure out if you're interacting with a GPT and interacting with a person, that which one is the person, which one is the GPT. So, but they had done some with investigation, but we are very close on breaching it, right? So there are now people are passing exams and submitting papers without necessarily being detected what it is, right? Unless you, of course, go through another software to detect whether it is through GPT or otherwise, right? The point again is that a lot of these things which we thought will be challenging, where the agentic AI in many of the functions will start to sort of perform as well as a human, and hence the dynamics are going to dramatically change from that perspective. Just to sort of highlight that, so now if we schematically look at the world, this is what we are looking at. So it's no more just individuals with some technology around them and then interacting with other individuals. You will also be interacting a lot with autonomous agents, not knowing that you are actually interacting with autonomous agents. So many of these, of course, your chatbots and all sometimes are very convincing and so on. So things are going to change dramatically, right? And hence, all the things that we talked about in terms of the sequence where, augmentation of capability and eventually negotiation and trade-off will start to be something that we need to reflect on. And similarly, extending our the same TMS assessment framework, if we start and bring this human to autonomous agent as one of the interactions to be in, we can again start to look at how readily accessible is the autonomous agent, like your GPTs. What would you allocate to yourself? What would you allocate as a task to the GPT? How much will you rely on it? How much do you trust it? If you were to build your own sort of account of a GPT, what would you keep stored there as your own sort of database so that it can help you with your own? So essentially like a RAG. And how central does it become as part of your day-to-day activity and things like that? So you can start to analyze this and see where we would like to be and where we are, right? This is another paper which sort of we wrote with one of the students I was advising at Stanford. So he actually looked at a digital twin from this viewpoint of a level of autonomy. So what we are looking at is what is the extent of autonomy that you can give to an agent, and how do you want to use that agent, right? So a digital twin, you could use a digital twin only as an observer. You just say that, okay, you collect all the information, pass it on to me. Basically, it's like a clerk in the office. You ask them to collect all the thing, and then you are the analyst. Or you can hire somebody to be an analyst. So they collect all the information, they also analyze it, and then present to you, and then you are the decision maker. Or you can hire somebody to be the decision maker. You can not ask them to not just collect information, analyze it, but also propose a decision. You can decide whether you actually agree with the decision or not. And you can decide to take an action or not. But they can give you an output, an insight, and a decision, and you may or may not agree with it. Or you can entirely rely on that person that you have hired. You say, fine, I'll give you all the authority to go ahead and also and execute the action, right? All these possibilities exist now. How do you deal with it? Depends on in which project you want to use it, right? So this is where we sort of proposed how to handle innovation, adoption of these more intelligent digital twins, in which kind of projects you could start to use it, right? So if it's a routine support required, where you want to just reduce the human effort, these projects are quick win projects, very doable. But the dream projects are where you want the tool to do non-routine activity and humans get replaced. That's still a dream project. We are not yet there in terms of the tool capabilities. But that's where you can start to strategically analyze where do you want to be, what kind of projects will you use for which kind of experiments, and how do you advance, if you are working in a company or otherwise, how do you advance adoption of these tools in practice for different activities, right? So with that, then the question comes, given that this human computer capabilities are changing, the role of the human has to be decided. How much do we want to do and how much does the computer does? But if you want to be in control of things, then you need to think, what is the specialization? What is distinctly human capability that will always give you that advantage, right? So then the questions come is thinking paradigms. What are we are good at, design thinking, systems thinking, computational thinking, but thinking is still a reasoning process by and large. And potentially that can be, and we hope that can be automated. What is increasingly difficult to automate, though we have been doing a fair bit of research. When I say we, means everybody as research community. There's a lot of work going on in affective and behavioral side, but that's still a long way to give, where emotional and other aspects become important. Where we are definitely far ahead is things like philosophical stance, even function attribution. We attribute function to something. That's a very human judgment, which is very difficult for a computational system to entirely do. Things like ethics and morality. I was glad to see the titles of some of the talks that are going to happen. Semiotics, which is giving meaning to something, is a very human thing. We give meaning to life, meaning to things, right? So these are things which are philosophical in nature, which will be, I think, our forte as we go along, and many of these things will change the dynamics of how we look at things. From a design perspective, one of the things that we have been trying to understand is what are the dimensions of design which we don't normally talk about. So in engineering, we typically are very driven by objective measures, KPIs, and to some extent methods and tools, operative, but we are not particularly strong on subjective things like emotions, philosophy, aspirations, rhetoric, persuasion, and then again on the social side, things like social desirability and things like norms, conventions. I think these are the things I think where we can start to bring more and more computation to these things, because that's a space where there's a lot of advancements still to be made, and we still have a lot more control on the human side. So with that, I'll stop here. Sorry for the very quick and fast-paced touch upon a number of concepts. By and large, what I wanted to discuss was essentially that decision support systems and transactive memory systems augment our capabilities, and they are everywhere in different forms. You may not have heard the concepts as TMS and all, but we are using it on a daily basis. And increasingly, what it means is that we are increasingly dependent on these decision support systems and transactive memory systems. Tools like generative AI and all have broken the barrier of access to it, which means increasingly society is going to be increasingly dependent on it. And we all are, for good reason. I think there's a lot of capability and a lot of advantages to doing that. But it also means we do not know, where this boundary will get blurred, or in our capabilities and the capabilities of these tools, and how much do we start to trust? Do we start to trust the output of a generative AI or these tools more at some point than we do from a friend or otherwise, right? So this shift will happen very quickly given the pace of development and so on. So we need to have a strategy of how to deal with this emerging transactive system, right? So with that, I'll stop here. I'll be happy to take questions. Thank you.
Thank you, Dr. Singh. Hopefully, I'm audible clearly now. I heard there was some issue with my audio before. So yeah, that was a really great presentation. I really liked all the analogies that you provided throughout your explanation. And that's from someone so I don't work exactly with AI and LLMs, but it was easy for me to follow through with all the analogies you gave. So with that, I would like to open up for questions. So if anyone has any questions for Dr. Singh, please ask them.
Can I have a question? So first of all, I would say thank you so much for the presentation. It was not only interested to me, also kind of strange, because my research area is very close to the talk that you presented today, and your work and your team that's already done. So one of my questions is that in your presentation, you mentioned about the satisficing. So I would like to know about satisficing strategy. How did you use in your work? Is that relative to bounded rationality or something like that concept?
Yeah, so I think from a satisficing perspective, first of all, it also depends on what stage of design interventions you are involved in, right? So if you look at in engineering design, a number of people are working in the space of optimization, even in generative design, so topology optimization for that matter. So that is one way to look at research. So my research has been in the early concept design space and design exploration, where we are looking at not looking at detailed design in terms of so there are two parts essentially. Now, just to illustrate an example again on satisficing. For example, let's say you go from your home to the university every day, right? And you take whatever is the convenient route that day. You do not necessarily optimize that this is the shortest route, or this is, it's going to save me the whatever, right? So on a day-to-day function, you have multiple possibilities, and you take one of those possibilities, which seems to be reasonable. Now, when we are looking at in the early design phase, in the early design phase is where you make commitment to what you are actually going to design, right? Because what happens typically is that we quickly wrap up the early design phase, and we spend majority of the time in optimizing that one solution. So you're already suboptimal in the concept that you have chosen because you have not explored the design space enough. So what we are looking at right now is that we are looking for even though we are saying satisficing, first of all, our objective is to expand the design space. So we are looking at alternatives, design alternatives, rather than looking for the, detailing it at the moment. And within that, we are not, and hence then the question is that the alternative that you are picking, of course, is better amongst what you have explored. But we are not necessarily trying to prove that it is optimal. It's meeting the requirements, and within the time frame and the exploration that's possible within the time frame or otherwise, we are saying that this is what we are seeking at this point. In the implementation sense, in the generative design context, that is what it is. Then from the behavior, so a lot of our research is also on the behavioral side. When we are looking, for example, I'll again connect this to another research. So this another research where we are looking at, I'll have to give some background. It might take 2 or 3 minutes. So very quickly. So one of the things we have argued is that the construction industry as such moves slower than other industries in terms of technology adoption, right? So if, for example, if you take a tech industry like computers, so maybe the algorithms that you use today, or you use, say, or leave algorithm, let's say hardware. A hardware that you used 6 years ago may become obsolete by now, right? You can't be using the same hardware because it becomes too slow and doesn't match your requirement in terms of your speed and processing capabilities and so on. Whereas in construction, you might still be living in a 200-year-old building, and which might be functioning just almost as good as your 10-year-old building. There might be some exaggeration to it, but if you look at the technology advancement, there's so much that happens, but by and large, the buildings around you do not necessarily use this most advanced technology that is available, right? And there we started to look at what is it that people really actually give priority to when they buy property, right? When we started to narrow it down, we started to look at the behavioral side of it, and what is it that people do not necessarily look at optimal solution when they buy property, right? They are looking for good enough house, which meets their requirement. And that decision is largely determined by location rather than the actual build of the space. There's enough evidence of that we found as well. So when we talk about satisficing, a lot of that is determined by what we are looking at in the decision process and what determines the decision making. And by and large, in most of the context, we see that the decision making is not necessarily towards optimization, but towards finding good enough solutions. And that is our stopping criteria for most of the research spaces.
Thank you so much. The overall, it's very close to my research, and I have to go through the papers and your books. Sure. And we'll be in touch with you offline after this meeting for sure. Thank you.
Thank you, Siavash, for that question. Anyone else has any questions? Rodney?
I don't think I have any. I don't have my thoughts put together well enough to ask a question right now, but maybe in an email.
Sure.
Okay. Anyone else? Question? So actually, I had a question. So when we were doing that, the thing with that design of a pencil thing, so we know that the GPTs and like all the AI tools available right now, they are trained with data that directly comes from the human research and everything. So do you think that kind of bias to things like how we have a bias of, let's say, how a design of particular thing is or has to be? So do you think the AI also has that built in because of the data it is being trained on?
Absolutely. That's what I was trying to say, which is that, see, eventually everything is about the data, right? It's inductively being built, right? So, right, we also learn from the same data, and that's why we get bias, right? Where does our bias come from? Our bias comes from our ability to see the pattern, first of all. So that's actually a good thing that we are able to see patterns, which allows us to learn some things common and generalize it in situations that we have not seen before. So that is, in other words, we call it stereotyping, where we have stereotyped and we know that, okay, this might be an explanation of a pattern that we are seeing. But if you apply that pattern that you see without knowledge of the bias, that is when it becomes a negative thing as a stereotype, right? But the ability to see the pattern is a great thing. The same thing is happening with all these tools. We are essentially, if it is data driven with large amount of data, you are largely looking for inductive patterns, and you're learning from those inductive patterns, right? When you have, so whatever is the data that is available, especially with some of these tools like GPTs, because they are taking trillions of data points, right? Which means that many of those data points will also need not be the most accurate data points, right? So whatever is in the public domain, it's building on that. And that is what we found, in fact, when we were trying to use FBS also, because the general definition of FBS, of how people have defined the function, may not necessarily match with how neatly we have defined what is the function. So we had to, when we actually had to adjust our definitions to get better results, to suit what GPTs were looking at as behaviors or looking at as structures and things like that. So that is where I was saying that, right now results are largely based on inductive patterns, which already looks phenomenal because it's so much data, right? We are also largely, our intuition is based on those inductive patterns. What is missing is, so it's essentially the same thing which is being discussed, which is a combination of data-driven models plus model-driven, data-driven techniques plus model-driven techniques, right? It's the same thing which we'll need, which is that you need to have sort of causal models which will support and collaborate with your inductive models in your GPT, so that you can write better prompts and also analyze and score them better. So you have to combine causal relationships with your inductive learning. I think that is where I think there's still quite a bit of work to do. And that's where we find also in the FBS reasoning, we have there are a lot of interesting things to come out from our group also on advancing in the FBS, which has not really seen major advancements since the 90s. I think hopefully we'll be able to make some interesting contributions there, largely learning from this project. So yeah, so definitely I think principles-based knowledge will be extremely useful. What is very interesting, of course, is that given this large amount of data, and if we have the right causal questions asked, it's an opportunity also to make new knowledge discovery, fundamental discovery, if the right kind of questions are being asked.
Thank you. And also, I think probably, I don't know if I'm right or wrong, but I think the bias not only comes from the data that it is trained on, but also another added layer of bias from the user that is using it. Like if we try to look for certain things, then the future responses are tailored according to what has been searched before.
Right. Yeah, so absolutely. So this is where the problem formulation becomes extremely critical, right? That's why what is the hypothesis that you have, or what is it that how you're formulating the problem becomes super critical, because in your problem formulation itself, you might be having some biases as well as something that assumptions which sort of limit what you was potentially getting as. That's why, I mean, in design literature, it's well acknowledged that, at least, so if you go back to, even if you're familiar with this double diamond framework in design, and any of these for that matter, it says spend a lot of time initially just understanding the problem, and you should be very willing to reformulate the problem. Because when you start, you'll not necessarily have a complete information, which is what I was saying, right? So you'll not have a complete information of the problem. So unlike the traditional way that you say, I've started with this problem, so I have to find a solution, you should be as willing to change the problem, because now you know that probably what you started with was not adequately understood.
Yes. Thank you so much. Is there any other question? Okay, so I think that I will thank you again for doing your presentation with the GSC Fall 2025 webinar series. Hope we can have you again in future with some more of interesting topics from your work. Farooq, would you like to add anything? You are muted, Farooq.
Vishal, that was an absolutely phenomenal talk on what you touched upon, particularly the way in which you went through the function behavior structure and the expected behavior and the actual behavior, and how one goes around the function behavior structure to make things happen. In addition to that, the emphasis on satisficing and Herbert Simon's view of design, that is, go from something that is unacceptable to making it acceptable, I think is an extremely important construct, and it flies in the face of what most people talk about in terms of optimization and things like that. So I'm most grateful for you to have brought this up. I do have a comment. When we use LLMs, one of the things that is not clear to me, and we don't have to answer that, I want to leave that as a thought for everybody, is will an LLM be able to speculate about the future? That is not clear to me because, for example, if you're thinking of entrepreneurship, if you're thinking of doing new things, being able to speculate is extremely important. And it is not clear to me whether an LLM will be able to do that in the near or distant future. Why? Because to be able to speculate, you have to be able to conceive, you have to be able to perceive, these are human characteristics. And I cannot see a LLM being trained to speculate in terms of conceiving and perceiving. So with that, thank you all very much. It's really great. I much appreciate your willingness to stay past midnight in India to give this talk. Thank you. And thank you, Swapnil and everybody else. Bye.
Thanks again, Farooq. Thanks for having me and the entire team. And thanks, as Farooq said also, that it's good to see that some of you managed to stay all through. So have a good day, and I hope you found something relevant for your work as well.
Thank you.
Thank you.
Thank you. Have a good day. Bye.
Bye.